Hi, this is Brian Duclos and welcome to my portfolio. In this video I'll be looking at some code that I did for our Capstone project last year. First off, I'd like to look at the dynamic split screen system. Now, the dynamic split screen system is comprised of multiple cameras and basically a camera on each player, so one on this player, one on this player, and one split between the two in the middle. And then one camera, those cameras that are on the actual play area, stream to textures that are over here. And I have a block that has shader code that angles to basically delete half the screen and a black bar right in the middle. So we'll just dive, before we dive into the code, we'll look at what this actually looks like. So this is actually in-game, and so what we can look at here is this black bar in the middle and see how it angles. And this is actually because the screen is splitting. And then the reason why we have the camera in between the two is when they come together, we wanted one single view. Now, this allows players to be able to see each other or get a general location of where they are on the map without actually seeing each other. A lot of time was put into making this a smooth transition. Actually, let me start it back up again, and I will show you what this kind of looks like as the game plays. So as we can see, the objects that the screen is on actually rotate around the cameras right here and angle themselves based off of where the players are in conjunction to each other. Now, the code behind this is right here. This is the code for angling the two objects between, or angling the two objects based on their camera position and offset, the shader, and the actual player positions based on one another. Here's a script to when they go to one camera. It's basically just a distance thing, and then also plus a zoom factor based on how far out they are from each other. Here is setting the render queue for the object that actually, this object right here, the dynamic mask. And then here is my very short shader code. Yeah, so that's basically the dynamic split screen. I enjoy it because I think it's an interesting solution to a problem that is also quite interesting, and I think it shows a creative way of getting around many obstacles. So let's look at something else here. This is the generation of the dynamic nav mesh, or navmap, for our AI. Here we can see the generation of the actual nav map in these lines, and what it does is it takes in the here we'll just go to the actual here, I think, here we go. So it takes in the max X and the max Y based off of this, which is basically just a see-through object that's the actual play area that the players are actually able to be in. And you can just drag and expand this as much as you want. And then you add in the distance between each node, and yeah, line cast between to create the actual map. Here, down, oh no, up here. This is the actual navigation algorithm. I used an A-star algorithm with a heuristics of distance traveled plus distance to objective. And it's pretty simple stuff of the A-star. here's the actual calculation, plus a little nudge factor used to round values just to make sure that they're not exactly the same. And then deconstructing the path and returning the path. And speaking of the actual navigation map, well, we'll look at how it's actually, or how it actually looks in game. So here we can actually see, sorry about the UI, but we can actually see the navigation map that's used. And yeah, so we can see that the spikes, it doesn't generate on them, but say that we, maybe we'll just delete one of these columns here, get rid of one of these columns, regenerate it, and we can see that it actually goes on it again. Activate the column, and we can see that it will make the AI go around the column. Ta-da. Now, as for the actual AI, I used a state machine because we have so many different types. You can see all the different types. If you look at my mouse right now, we have one called the Angry Boy, we have a Boss, a Centaur, Doomba, a Roamer, Stalker, and a Yo-Yo. And then the general states of different, what all AI basically are taking, or at least some of the AI have. So this is the searching for player state, for instance. It doesn't know what player to actually go to, so it chooses the closest one. If it doesn't already have a player in its sights. Run off screen is when the boss state comes. They all run to the designated exits, which are wherever the nearest spawn points are. So this is a showing of what the basically AI or tools that I developed for the designers to use. So it's a basic drag and drop thing, just like how I do for the wave, which I'll show very soon. But basically all they do is create a spawn point object with the spawn point script, move it to some place in the screen. I apologize for that. Yeah, that's basically it. And then they have a spawner for each of the players, and the actual number corresponds to, and the player ID corresponds to what the actual player the AI will target, because both players have distinct AI that they can be on different waves of AI each player. The wave manager is my I think it's the coolest thing that I made for the designers. It is a manager that allows the designers to just use drag and drop waves. So they just drag them underneath the wave manager, and the players share one wave manager. They drag them in, and whatever order that they're actually in, it doesn't matter about the numbers or the naming or anything like that, but whatever order they're in, going from top to bottom, is the wave order. And then in each wave you can change what creatures are going to spawn, their actual spawn rates, the number of seconds in between spawn, the maximum there can be on screen per player, and the number that the player needs to kill to advance on to the next wave. And here is the wave manager code. I use a enum trick that we learned earlier last year to eliminate switch statements further down based on what the player has killed. So it's down in here to update the UI. And that has that. This is what the wave looks like. And the other major thing that I did is I developed the idea for the actual variable manager for us to have all the variables in one place for the developers, or designers I should say, to just have an easy place to go in, edit, like for instance the roamer. I'm pointing with my pen, but they could go in here, edit the health, the speed, and all the different variables that they would actually need to change at any given time. I think we actually made, me and the other two programmers that worked on this project, I think we made a lot of really great tools for the designers to use. I I think that they are actually very modular in the fact that they could be taken out of this game and basically put into another game without very much hardship. Yes, I will be putting this game on the portfolio